All right, welcome everyone. This will be a video on how to read a graph, right? Namely, how to read what's happening to a particle on a position versus time graph, like we see here, on a velocity or speed versus time graph, like we'll see next, and on an acceleration versus time graph, which we'll see towards the end. So if you would like to, before I get into the details of what's going on here, if you would like to pause the video and try and predict or guess yourselves what's going on, feel free to do so now. All right, so now let me move on to explaining what's actually going on. So this is a graph, right? This is symbolic of the position versus time of any particle. It can be, I don't know, a point particle like an electron. It can be a car. It can be someone walking. It can be anything at all. It's just a graphical representation of some object's position in space over time. That being said, this blue line is what we're going to look at specifically. So let's take a look at point A to point B. All right, remembering that position relates to speed like such, right? The speed v is equal to the change in position x per change in time, t. You can also think of this as the rise over the run, right? So let's take a look now at the rise over the run for some key points, right? Rise over run, you know as a slope of a line. At point A, what's that slope of that point right there, of the line at point A rather? There's a tangent line. That's pretty close to horizontal, right? So the slope is 0. Thus, the position isn't really changing, right? And the speed isn't changing. It's 0. So really from time 0 to time 1, the slope stays 0 and this particle does not move. But now let's take a look at from about 1 second to 2 seconds. There we go. From 1 second to 2 seconds, the slope at 1 still pretty close to 0. At 2, it's increased, right? It's become more positive. Trying to do that, right? Versus that. So from 1 second to 2 seconds, that slope, right, the delta x over delta t value has increased, and the position of this particle has gone from 0 down here up to some value of, say, I don't know, 1 or so, right? So not only has the position increased, but the velocity or speed of the particle has increased, right? And we see the speed has increased because the slope has increased in magnitude. Now, going on from 2 seconds to 3 seconds, the slope has increased slightly more to whatever it is there, right? So really from point A to point B, the slope increases from about 0 to, well, whatever it is, okay? And so we can say that the position of the particle goes from 0 to about 4, and more importantly, the speed increases from 0 to whatever value of slope that line is right there. And we'll see that on the very next graph in a second. Okay. From point B to point C, what happens to the slope? Does it change? Does it remain constant? At all of these points, at point B, say at 4 seconds, at 5 seconds, at any point between those, it's the same slope. It's a straight line, in other words. So this delta x over delta t, that value for the speed is always the same. So the speed does not change. It has a constant speed, in other words. Constant speed means that the line on a position versus time graph is a straight line. Okay? And that's what we see there between points B and C. from C to D, what's happening to the value of the slope, right, or tangent line? Well, it's going back to 0. At point C, it's something like that. And then it's decreasing like there and then back down to 0. So what's happening from C to D is that this particle is slowing down, right? It's decreasing speed. Decreasing speed, but still moving in a positive direction. Okay, that's an important distinction. It's decreasing speed because the tangent line is going from a positive slope value to 0, right? So that's getting smaller. However, looking purely vertically along this axis of position, we go from this position of roughly, 24 at point C to point D's position of about 26. So you can decrease speed but still be moving forward. That's what's happening with this, I guess it's a concave down slope. Concave down curve, right? Conversely, from point A to B, that I forgot to mention, that's concave up. So what's happening there? Well, the particle is speeding up as it's moving forward from position 0 to position 4 or so. Okay, and that's concave up. Two important distinctions. So in fact, let me write that on here. So let's see, right in here, it is, let's see, slowing down, in other words, decreasing speed, but still moving forward, right? And by forward, I mean the plus x direction. Over here, from point A to B, what's happening is that it's, speeding up. It's getting faster and faster because the slope of that tangent line is getting from 0 to some positive number. And it is also moving forward. Okay? All right. So that was reading a position versus time graph. In the next video, I will be discussing the velocity versus time graph that relates to this graph here. Okay? All right. Thanks for watching.